In this lecture, you'll learn all about level of measurement of data. So let's have a look at it. So first we'll learn all about scale levels, so how data can be scaled in general. Then I also want to explain you what are scale levels needed for, and also which characteristic has which scale level. So I also want to give you a lot of examples, and then you can use this basic concept also for your data, since this is also really important to determine which specific key figure you can apply or able to apply for your data. So level of measurement is a really important concept. It is a classification method, and with this method we can describe the nature of information, or let's say the type of information of our assigned data. And by speaking about level of measurement, it is also quite important to speak about measures and scaling in general. So one really important word is also characteristics. So what is the meaning of characteristic in statistics? So a specific characteristic is exactly what is asked about in a statistical study. And therefore we can also have characteristical values. So this is really a concrete value that a characteristic can assume. We will also see that, of course, later in an example. And also important is the characteristic carrier. Those are just the elements that have the characteristics which are relevant for us in our survey or in our project. So let's further speak about level of measurement, and I want to illustrate you now the specific levels. So let's talk about the first level, which is the nominal scaled features. So our characteristics or our features of data, they can be scaled in different levels. For instance, they can be scaled nominally. So that means that we cannot create a ranking of our characteristic values. So we cannot say one characteristic value is better or worse than the other. And we also cannot say that one characteristic value is bigger and smaller. So for instance, if we take the characteristic gender, then we cannot claim that one gender is better than the other. So we cannot say that men are better than women or vice versa. And also if we take another characteristic such as the preference of music, for instance. So if we take different categories, so different characteristic values such as rock music, metalcore music, but also rap music or pop music, we cannot claim that one characteristic value is better than the other or worse than the other. So this is not possible to create a natural ranking. As a result, it is also not possible that we calculate arithmetic figures. So it's not possible to apply arithmetic operations. And besides those nominal scale features, there are also the ordinally scaled characteristics. So the difference here between the ordinally and nominally scaled features is just that here we can apply a natural ranking. So we can say that one characteristic value is bigger or smaller than the other, and also a better worse relationship is possible. So a really popular example is or are the school grades. So there we have the characteristic values very good, good, and also satisfied. And there we can of course say or claim that very good is even better than good. But the thing is here that we cannot quantify the distance between the characteristic values. So we cannot say that very good is 1.5 or anything units better than the other characteristic value, so good. As a result, there's also the third and last scale level, which is metric scaled features, or the scale level metric. And there we also can create a natural ranking, But a distinction between the ordinal and metric scale level is just that with the metric scale features, we can also calculate the difference in detail. So that means we can quantify the distances. Those differences are quantifiable. And as a result, also all mathematical operations basically are allowed and we can apply them. So we can, for instance, calculate an arithmetic mean for numerical data, so for metric scale features, but also standard deviations, correlation metrics, and so on. So as you can see, there are different scale levels, and this is pretty important if we have a look at our data later. So let's have a look at some examples, and let's commence with the metric scale features. One example would be here the revenue, because there we talk about numerical data. Just because every single characteristic value is with a high probability different than the other. That means that we have different figures, as you can see here, in US dollars. So for instance, I could have $65.9. I could also have a revenue of $94.59 or $84.4 and so on. And as you can see, I can create a ranking. So I can say that the $90 is higher than the $60. And I can also say the $6 is smaller than the $70. Also the same with the quantity. There I just have a different unit. But anyway, this is also metric scaled. And I can say here this is in pieces. For instance, this figure is smaller than this figure. And also here, the length of this video you are currently watching, you can also quantify in video minutes. And there you can also say that it's possible to create a ranking. And then we have here the difference with the ordinally scaled features, such as the customer satisfaction scale. So I just scaled it because normally in Excel, for instance, we can just work better if this is scaled. So 1 would stand for the customer is very satisfied with our services, for instance. 2 would be representative for the customer is satisfied. 3 would be neutral, for instance. And 4 would be dissatisfied. Then also the school grades, there we can also claim that one school grade is better than the other. So we can also create natural ranking, but we cannot say how many units there are. So we cannot quantify the distance or the differences between. And last but not least, we also have the nominal scale features, such as the gender, so male, female, or the eye color. So eye color green or blue, or the eye color brown, and also the skin color. So there we cannot claim that one or another characteristic value is better or worse than the other. So we cannot create a natural ranking. Another example would be this here, what you can see. So let's talk about a feature in a survey, like the gender. And then we also have the feature career, like Max Smith, for instance. And he is the object or the person where we assign the characteristic value. For instance here, whether he is a male or a female. And then you can already see male. And then of course we also have our level of measurement, which is nominal scaled. And in the end, also another hint, there are also some synonyms in terms of the wording. Usually we also call the nominal scaled features, we also call it categorical data. And also with the metric scale data, we also say those are numerical data or numerical scale data. And in the end, also here the list of references, and this basic concept is really important, and now you are aware of those different levels of measurement and can use this concept for your data.